So this session is about virtualization through containers. First, who am I? I'm Toshaan Bharvani. I'm from Belgium, Antwerp, self-employed. I do security and virtualization, mainly involved into enterprise Linux. So my examples are mainly focused on Red Hat Enterprise Linux. Yeah, the rest is basic stuff, Twitter account and a website. So what I would like to do is give a short introduction, then tell you how you can set it up, and then try to do a demo. The demo will depend on the internet because you need to connect and everything. So yeah, I presume everybody knows what virtualization is. For those that don't know, well, it's basically running multiple machines on one physical machine. You can do that in different ways. And the most common ones are full virtualization, which has been done since the late 60s. So it's quite old. Those are some examples. Hardware-assisted virtualization is the one that came to light in 2006, mainly through Intel and AMD having the VT-enabled processors. It's also when the more common use of virtualization came into known. So you also had partial virtualization, and para-virtualization, which is virtualization without hardware assistance. Then you had operating system separation, which some people call Cgroups or containers or partitions. So you have, like in the proprietary world, Sun had something called zones. HP Unix has their version of it. IBM has their version of it. The most commonly used in the Linux world used to be OpenVZ. So LXC and OpenVZ are quite similar on many points and a little bit different on a few points. And then you have, of course, emulation, which basically allows you to run any type of emulated environment on a machine. So what is a container in Linux? It's a virtual environment. It's not a real virtual machine, and it has its own resources in the sense that it can address specific devices, files or file systems independent from the host host machine or host operating system. So it allows you to isolate applications or operating systems. It can even isolate processes. So in LXC, you have two different variations. One is called the application virtualization, and one is called an operating virtualization. Operating virtualization means that you're going to actually have a full chroot running with its own paths in there. In an application virtualization, you actually only isolate that one particular application in a confined manner, and for that you use Cgroups. I'll be going shortly into Cgroups because we need that to run LXC, but I'm not going to go into full details about Cgroups. Because it's basically running within the same operating system and using common resources, the overhead is very low. It gives you near native performance and was included in the mainline kernel 2.6.29. So one of the main differences with OpenVZ is it isn't in the mainline kernel. Currently it can only be used within Linux, and the machines also, or the operating virtualization is also for Linux only. So some differences between some older versions. So Cgroup was a method that was already known, but it didn't allow you to do resource management in the sense that you could not say, I want to give it that much CPU, or I want to be able to confine it to only allow to access one particular network controller. OpenVZ, the main difference is it's not a mainline kernel, so it doesn't have the full support, or it requires you to have a modified kernel. The one that you can find, which are standard built by the OpenVZ community, are mainly focusing Red Hat or Debian. So if you're running any other versions, that might not be the best solution. Images from OpenVZ are compatible with LXC. However, you will have to do a full configuration again. So there is currently no tool to migrate automatically between OpenVZ and LXC. As it's only a configuration file that you need to edit, it should be quite easy to do yourself. OpenVZ at the moment still has better disk management. So OpenVZ can run from a SAN. LXC at this point cannot run from a SAN. So it does have at this moment some advantages. It's of course more mature because it's much older and has been used much more heavily. Another counterparty is BSD jails. Obviously that's only used on BSD kernels, so it cannot be used in a Linux environment. Cgroups. So if you want to run LXC using the native tools, you will have to set up Cgroups. Most newer kernels have it enabled, but you need to have a daemon running in the backend to allow you to distribute your resources correctly and see that your processes are not over using your resources. So first what it does is it defines resource controls. It allows that on CPU level, on memory level, network level, and specific devices. It also has something called namespaces, so you can define a particular space on your file system that can only be used by a particular cgroup. So if you want to have a container, you automatically need to have some control about that container, and that's done by the cgroup actually. Oh yeah, apparently I forgot to escape somewhere. So by network it's net underscore ls and net underscore prior. So how do LXC and Cgroups work together? LXC runs as a separate process, and basically that process gets linked to a particular cgroup. Once you confine that once you define that cgroup and the process, it links it through a backend daemon and allows you then to say that, okay, I can only use, or a particular container can only use 50% CPU, can only have 10% of networking, or you can even define on the network card level how much percent bandwidth it can have. If you're running multiple containers on a same network controller, you can say one container uses 15%, the other uses 45%, and so on. So what does LXC have different than the other container systems? It's mainline kernel, it has a lower overhead, and it allows resource management, which is not always as easy with other tools. At this moment, it doesn't have a full security feature. There are some sandbox tools which allow you to confine it to its own location, but it doesn't allow you to always have the same security features as a full virtualization. The main difference is on the device levels. So whatever you have not defined can be accessed by the system itself, as it runs in the same kernel. My demo will be using libvirt. So how does libvirt and LXC combine? It's basically just another hypervisor that you can expose. So libvirt has different support for different hypervisors. LXC is one of that. Using the libvirt library, you need to have Cgroups, which anyway you want to have if you want to do container resource management. And now, at the moment, it only fully supports application containers. So operating system containers have been provided as an API, but if you try to use that through libvirt, you will see that you can still get some quite a lot of errors relating to connecting and network connectivity. Are there any questions about the first part? Yeah?
Doesn't libvirt support using LVM to create new volumes and mount them somewhere, so you could use a SAN anyway, simply by virtue of provisioning your container through libvirt?
Yes, but then you don't have the same control like you would have, for instance, in OpenVZ. You could specifically give a LUN number as a mount. Here you're telling libvirt to do that for you, so using an external tool. And then obviously it's just a mount that you see which is used as your CH root. So it gives you the possibility to get around certain things, but it doesn't give you the same full functionality yet. Any other questions? So how do you set it up? On most distributions, you just do yum install libcgroup or apt-get cgroup bin and libcgroup1. So the first command obviously is for Red Hat based. The second command is for Debian based systems. What you then need to do is start the two daemons. This cgconfig is where you write your configuration with the resource management in it. And the other daemon is basically the resource confinement daemon. What you need to remember is if you do this on a running system, you will have to restart libvirt daemon before it can recognize the cgroups. Because what it does is it mounts specific cgroups and uses your configuration file to basically create a layout of your resource configuration. So how do you control VMs through libvirt? You use the virch command. By default setups, it will connect to the QEMU backend. So what you need to tell him is, I don't want to connect to a QEMU backend, but I want to connect to the LXC backend. And then the commands are the same as you could do with normal libvirt. Some commands have not yet been enabled because it's not possible to do. Others will not be possible, like shutdown. You can't shut a container down because it cannot get an ACPI command. So the shutdown normally connects to the ACPI connector and then shuts down your machine. So you need to destroy it, which basically is a force shutdown. For the rest, they are all quite the normal libvirt commands. Any other questions about the libvirt? So then some examples. So libvirt uses XML files to define the virtual machines. So what you would want to do is define a virtual machine. This is a quite simple example. So it tells you what type of hypervisor you're going to use, LXC. You have to give it obviously a name, some memory, what type of virtualization you're going to use. So this would be a full OS, an application container, and you're going to execute the bin sh as your init command. And then some devices you can, so here you define a mount, which is then where your source is and where your virtual machine will see it. You can have multiple mounts there, and you can have a network connectivity which connects to the default network backend of libvirt. Once you have your file, you can import it with the virt define, and then it will convert it into a full-fledged XML configuration file. So you'll see that you have a UUID added. You can define how many CPUs. So if you have multiple CPUs, you can tell him, I want to expose one virtual CPU, and then based on the C group, you can define how much of that virtual CPU or physical CPU it can use. So here it basically converts what are the commands. Power off is basically destroy because it doesn't have ACPI connectivity. What it should do on reboot or on a crash. Then it tells you where the emulator execution command is, what it should do with the file systems. So it's a pass-through mount, and this gets exposed then. I have here two mounts, the basic root mount and an extra data mount. You could use that to exchange data with your virtual application machine. And in this case, I've given it two network cards, which enables you to have net provisioning or bridge provisioning. And then a console to connect to, obviously. So once you have done that, if you connect to your LXC hypervisor backend, you just type in your normal command, you'll get a list of the virtual machines running and an identification number. The identification number is your process ID number, which you will see is the same number as your process ID number if you grep on PS. Here you can also see that, for instance, which network controllers it has. So in my first case, I have one virtual Ethernet, and in my second case, I have two virtual Ethernets. So if I do ifconfig, I can see here the virtual Ethernets here are listed, which are connected on your device. If we connect, or if we look at the application, I don't think anybody can read that, most probably. No. Let's see. Well, I can't get it any bigger, but what you could do here is, for instance, see what file layout you can see from here. So that is its own file system, which you can see from your host machine on the same location. So on the host machine, you can see the full file system, which is listed here then, which is basically created at the time that you install your machine. You can then use yum or debootstrapping or FE bootstrapping to install extra applications within that container. Once you have, for instance, a yum running in your container, you can then use yum in your container to install applications in there. So in this case, I, for instance, installed an Apache server, and if you then just do the normal command restart, it will tell you that yes, it restarted. It's with the default setup, so it tells you it doesn't have a qualifying name to connect to expose, so it will be running on localhost.local domain. So like this, you would be able to confine your applications or provision separate instances of applications running in a specific container, because from here out you cannot see your real root system which is on your host machine. So you can only see what is exposed to that particular machine. From the host machine you can't see everything, so that is still an issue that might come up. If you are the root admin on the host machine, you would be able to get into all the virtual machines. So if I do a PS in the virtual machine, you see that the init command is listed there and my Apache servers. So within the virtual machine, you only see what you initialize or what you physically start yourself. Any other questions or yes?
You're using virt manager. Can you also use virsh, like a virsh console, some container?
Yes, normally it should work, but I think there's something wrong with my terminal setup, because normally you can do it from here onwards. But whenever I type here, I see nothing here and it comes out there somehow. So normally, yes, you can get it out here and you would just have your console from there and you would be able to do your normal work from there. Any other questions or? It's clear how to set up a virtual machine. So based on your XML file, it will basically, once you define it, create the template. The only thing you need to do is still create your file system itself. Yes?
Can you manage using libvirt the containers you've created using LXC create?
Yes, you would have to just write the small XML file and then define it, because it doesn't create the root system itself. So it will recognize that root system. You'll just have to tell it which is the init file it needs to start up from. Yes?
What version are you running on there?
Of
Kernel and
so my kernel is 2.6.32 220. It's a scientific Linux 6.3. But I'm not running the latest kernel because the latest one is 279-11, I think, at the end. Yeah.
Also, LXC will be better if you're running a recent 3.4, 3.5 kernel.
Yeah. So
There's been a lot of improvements.
So there have been a lot of improvements, and performance-wise, what you get in the mainline enterprise distributions is already quite advanced, but in feature-wise, it is still a big gap between what is in development and in enterprise. So, for instance, the SAN connectivity is available in the Devel 3.
How will we find the documentation? Because I tried something like this in February on 6.1.
I didn't know there was documentation.
Exactly.
So no, it is terribly documented. There are a few people who have taken some effort into writing how you can set up something small, but once you want to do really complex things, it's quite difficult for the moment. So like setting up a small Apache server, MySQL server, you should be able to find enough examples on the internet, and using my presentation, you should normally be able to figure out how you can get your daemon in there. It's basically just writing a simple XML file and then running dbootstrap or fe-bootstrap in your chroot environment. But let's say if you want to run an operating system application, operating system container, that's much more difficult at the moment.
So it's perfectly fine for people once they don't need to.
Sorry?
It's perfectly fine for individual Tomcats.
Yes, it's at the moment it's fully supported and looked at from an application point of view. So running 5 Tomcats, or in my cases, for instance, I'm running different versions of MySQL, so I can test my application against the different versions of MySQL. Yes?
Do you have the disk as a separate LVM partition, or do you have just bind mounted from subdirectory, and how do you then limit disk space usage?
So you can do quotas on file system level if you mount it. If you use an LVM, at the moment that's not fully supported, but you would be able to define the quota on the LVM itself. But there we have seen that if you try to do that, you get a lot of I/O problems. So performance becomes then actually unusable.
Cgroups themselves have limitations, right? You can
Yeah, so you can have namespaces on your file system and then limit the size on the namespace of your file system. And then if you limit that in size, that I only want like 1 gigabyte, or I only want 10% of my disk, so the container can only use that much resources.
Do you specify that in the
You-
LXC XML config, or?
No, you do that in the Cgroup config. I don't think I have a full example here. So here you could, for instance, tell Cgroups what resources it gets. So you give it a user, the controller, and here you could put a namespace then, and what is the limitation in destination and in size also. But it's not from LXC being configured, it's more from the Cgroups or from your file system level that you're configuring it. Any other questions? Thank you. The slides will be available. I'll put the XML files also somewhere online so you can look at them.